Hello, everyone. My name is Robert Way, and I'm the CTO of our project this semester. For this project, we are sponsored by Wartsilla, Finland, and we designed an AI-powered internal application manager. So as for the problem overview, Wartsilla came to us with over 27,000 installed applications across all their devices within the company. This poses many security risks as a lot of these applications are outdated and contain many vulnerable CVEs. They also are just redundant and they lack standardization. And then another thing they stressed to us was the different licensing restraints posed by many of their different applications. So the goal of this project was essentially to create a unified system that analyzes all of the data they sent to us. This system would classify all of these different applications along the lines of commercial licensing, um, security, and then furthermore, categories, just to make it easier for the user to search and sort through all of the different applications in their different devices.
Howdy, I'm Joe, and I'm now going to introduce our data pipeline. We start with the Microsoft Defender data here. By using the Fast API, we ingest and normalize thousands of applications records so they follow a consistent format. Once the data is cleaned, we run three AI-driven workflow: the CVE risk evaluation, categorization, and AI-powered license detection. We also use a fine-tuned DuckDuckGo-based web scraper whenever additional information is needed. All enriched results are stored in our curated catalog in the PostgreSQL database. This catalog is then connected to our Next.js administrative dashboard, giving IT team an up-to-date view of risks, categories, and recommended applications. The data pipeline is fully automated and supports scaling across Wartsilla's global operation. Here is a simplified database overview. Everything begins with the normalized applications. It stores the clean application name, vendor, version, and the AI results. Each table focuses on one aspect of the application, which makes update easier and keeps the data clean. We summarize it as having the following benefits: a cleaner data model, a more modular AI workflow, reduced storage, and better integrity and safety. Overall, this design allows us to integrate multiple AI models without clustering the system and explore future expansion.
My name is Mei He. I'm the team COO. We have three key features. First is automated filtering and license detection. We automatically identify vulnerable, outdated, or unlicensed software using CVE data and license checks. This helps reduce risk and manual work for the IT team. Second is the AI-powered categorizations. We group each application into clear categories, such as communication, development, or productivity. This makes it easier to standardize and to find the right tools. Third is the administrative dashboard. This dashboard gives IT team a real-time view of application security, usage trends, and compliance. We centralize everything into one place. Then is the dashboard demo.
So here's the landing page when you first load into our application. And so the general workflow is all of the unscanned applications will be displayed under this tab, and you will simply start the scan, and that will go put the application through our pipeline, which will then classify it. Once the scan is completed, it will be sent to the review section where a human will be able to review this application. They can make edits. So say, for example, they actually deemed this to be a critical security application, they could change that and then save that changes. And then once they are satisfied with all of the changes, that can be approved and sent to our known applications section. The known application section is really nice because the users can sort by different categories that our model classifies applications as. And then furthermore, these can be listed by vulnerability, for example, if we wanted to display the most critical applications at the top. All of these different applications can be sent back to the unscanned section where we can rerun them through the pipeline. And then they can also be sent back to the review section if we want another person to take a look at those. And then lastly, you can simply just look at the information associated with each application within the known application section, including all of the CVEs associated with the application.
Next is the added value. First, it improves efficiency. We automate the entire process of filtering and classifying applications, which saves a lot of manual work. Second, we increase security by identifying any outdated or vulnerable software using CVE data. And finally, we support standardization. The system helps maintain a consistent approved software ecosystem, so employees are using the right tools across the company. For ethics, our priority is keeping data safe and handling everything responsibly. We don't collect or store any sensitive personal data. The system is used strictly for software analysis and security improvement, nothing outside that purpose. And since we use AI, we actively monitor the categorization process to avoid bias and ensure fair results.
Here's some future work we may consider. Due to the limited resources and human labeling constraints, we only doing the model by using the generative AI, but not the traditional regression AI. We should consider adding this and compare the result to see which is have more performance than other. We should also improve the license detection method to classify with devices information that have some cross-platform identifier. The third one is to integrate real-time Defender API, as we currently only have the synthetic data Wartsilla team gave us as a database schema. We should also expand the dashboard for global operation and maybe have a chatbot integration for user self-services. This is our presentation. Thank you.